You know that feeling when you and your team are just putting in massive effort, like pulling 60-hour weeks?
Oh, yeah. Sweating over absolutely every detail.
Right. But the project just isn't moving forward. You're burning the midnight oil. The stress is, it's through the roof.
And yet, when you look at the actual progress, you're exactly where you were 3 weeks ago.
Exactly. It's like you're flooring the gas pedal. The engine is screaming,
Burning fuel at an incredible rate.
Yeah, but the car is just stuck in the mud, going absolutely nowhere. And actually, it feels worse than being stuck in the mud.
How so?
It feels like the mud itself is actively fighting back, like it's resisting you.
Imagine you have this massive, highly intricate piece of machinery, like a huge engine block.
Right, a purely physical mechanical system.
Exactly. And over years of just, absolute neglect, the internal components have completely seized up.
The pistons are locked solid.
Yeah, the gears are literally fused together by rust and grime. Now imagine a mechanic walks up to this totally seized engine, nods solemnly, and just pours a gallon of premium high-octane aviation fuel directly into the tank.
Expecting it to, suddenly roar to life?
Right, expecting to just break the sound barrier. But, you don't get forward momentum in that scenario.
Well, you get a catastrophic explosion.
You get heat, you get warped metal, and you get pure destruction. And so today, we are going to explain why your company's $14 million wellness program is doing the exact same thing to your workforce.
It's a devastatingly accurate physical metaphor, really.
It really is. Welcome back to our ongoing deep dive into the absolute, literal mechanics of human organization.
We are watching executive teams globally attempt to fix literal mechanical failures within their organizations using, and this is wild emotional poetry and meditation apps.
And the physics of the universe simply will not allow it. So if you've been following this series, and wow, we are now on part 4 of 8, we are systematically dismantling the modern corporate illusion.
Piece by piece.
Yeah. In our previous discussions, we were looking at the massive macro-level collapse of the global economy, right? Yep. Tracing this terrifying $9.6 trillion entropy leak.
Which was a massive scale to operate on.
Exactly. But today, we are zooming all the way in. We are shifting from that macroeconomic atmosphere down into the literal mechanical management of the human nodes inside the corporate engine itself.
Which really requires a fundamental shift in how we perceive a business in the first place. We have to completely dismantle what the source material calls the motivation delusion.
The motivation delusion. I love that term. Now, at the end of our last deep dive, we left you with this somewhat ridiculous hyperbolic thought experiment.
Oh, the yoga mats.
Yes. We pictured our archetype executive, CEO 8, just completely losing his mind and replacing all the mahogany boardroom chairs with yoga mats.
Right, forcing his global steering committee to lie flat on their backs in the middle of a Tuesday.
Just to achieve some sort of collective infinite phase.
It was a comedic extreme, obviously. A way to illustrate the pure absurdity of using soft sociological concepts to run a highly complex physical system.
Right, but here is the terrifying part about that joke. The reality we are diving into today is uncomfortably close to the yoga mat scenario.
It really is.
Let's set the stage for you. It's a Monday morning. Our archetype, CEO 8, is reviewing the Q4 operational budget for his $40 billion logistics conglomerate.
A massive, heavy industry machine.
Yeah, and he's looking at the telemetry from his European logistics hubs, and physical output like the actual tangible movement of freight across a continent is down 12%.
And from a physics standpoint, that is a massive localized hemorrhage of kinetic energy.
A hemorrhage, exactly.
The system is just visibly failing to convert potential energy into forward momentum.
Right. So what is the proposed solution to this? His chief human resources officer slides a massive proposal across the glass desk to fix this catastrophic drop in output.
And this is where the reality mirrors the joke.
It's a $14 million line item. And what is this $14 million buying? A global wellness initiative.
Unbelievable.
It features AI-driven empathetic listening bots deployed on Slack.
Right.
And mandated resilience retreats for all the regional managers. And the justification for this.
Oh, the CHRO genuinely believes the workforce simply, quote, needed to feel heard.
Needed to feel heard.
Which brings us right back to the motivation delusion. The modern HR wellness industry is currently valued at roughly $94.6 billion.
$94 billion. That's staggering.
It's a massive, sprawling apparatus.
Yeah.
And it is built entirely on a fundamental violation of physical laws.
Wait, hold on. You're telling me a $94 billion industry is a mathematical impossibility?
Fundamentally, yes.
That is a massive claim to make to our listeners. Surely, out of that $94 billion, some of these wellness initiatives actually help people recover.
Oh, absolutely.
Like, you can't just dismiss therapy apps and resilience training as completely mathematically impossible.
Well, we aren't dismissing their value to the individual biological organism.
Right.
A meditation app might absolutely lower a person's resting heart rate.
Sure, it helps them de-stress.
Exactly. A resilience retreat might help someone process personal trauma. But we are not talking about individual biological therapy here.
We're talking about the organizational engine.
Yes. The mathematical impossibility lies in the expectation that repairing the emotional state of a single biological node will magically overcome the structural friction of the system it's embedded in.
Okay, let's make this real. Break down the disconnect for me here. Why doesn't a relaxed herd employee automatically translate to a 12% boost in European freight movement?
Because an organization is not a delicate psychological ecosystem. It's not a family, and it's not a community.
It's a machine.
If you want to manage it effectively, you have to treat it as what it actually is in the physical world. It is an open dissipative structure.
An open dissipative structure.
We always blame the wrong thing.
Exactly. We blame the people, we blame their work ethic.
Yeah.
But we almost never blame the physics.
We are giving you a radically new way to look at friction.
Absolutely.
To really grasp how deep this dysfunction goes, we need to look at how executives currently try to fix this $9.6 trillion leak. Because, it's not a secret.
No, everyone knows productivity is stalling. Everyone feels it.
Right. But the solutions they throw at the problem rely on a concept the source text calls sociological alchemy.
Sociological alchemy, I love that term.
It's so good. Explain what that means in this context.
It's this persistent, deeply ingrained belief that you can manage a physical thermodynamic system by managing human feelings.
Like trying to hug a machine into working?
Pretty much. It is the belief that if you just get the psychological phrasing right, you can alter the physical constraints of a system.
It's basically corporate magic. It's this idea that if the machine is broken, we just need to talk to the machine about its feelings.
Maybe give it a wellness day.
Right. Give the engine a wellness day and it will suddenly start running again. That is just staggering to me. That's like trying to fix a broken transmission by giving the driver a neck massage.
Exactly.
Think about it.
But before we get into the real mechanics today, we really need to define two critical terms that govern everything we're about to discuss.
Yeah, the physics terms.
Right. We need to understand the difference between enthalpy and exergy. Because if you confuse the two, you will bankrupt your team.
It sounds like an academic distinction, but it's not.
It is the most common mistake leadership makes.
Yeah.
Enthalpy is the total amount of energy in a system.
Okay, so total energy.
Yeah.
Right.
If you look at your organization, your enthalpy is your total payroll, the total hours worked, the sheer volume of human effort being expended.
Just all the sweat and tears.
Right. It is raw, undirected energy. Exergy, on the other hand, is the useful portion of that energy.
The part that actually does something.
Exactly. It's the energy that is actually available to perform mechanical work and drive the system forward.
So, to use our car analogy from earlier, enthalpy is the explosive energy contained in a gallon of gasoline.
Yes.
But exergy is the specific fraction of that explosion that actually turns the wheels. The rest is just, lost as heat out the tailpipe.
Precisely. An open dissipative structure. That sounds like something straight out of a thermodynamics textbook.
It is, literally.
So what does that actually mean for the manager sitting at their desk right now listening to this?
In physics, an open dissipative structure is a system that maintains its highly ordered state by constantly exchanging energy and matter with its environment.
Okay, so it has to consume things to stay structured.
Right. A hurricane is an open dissipative structure. A living biological cell is one. And a corporation is one. It is a literal engine.
And what's fueling this corporate engine?
That engine is fueled by three specific types of energy: monetary energy, temporal energy, and informational energy.
Capital, time, and data.
Exactly. The human beings within the structure are not souls to be nurtured.
Ouch.
Morally they are, but in the context of the machine, they are literal physical nodes through which this energy passes.
And according to the physics we're exploring today, the energy passing through those human nodes can only do one of three things, right?
From me, three things.
It transfers into forward momentum, which is what we want, right? Actual work getting done.
Yes, forward velocity.
Or it stores an inertia, which is just mass sitting there waiting to be moved.
Right.
Or, finally, it dissipates into the environment as useless waste heat.
Precisely. The open dissipative structure is a concept that demands we respect the physics of the environment.
So when modern management attempts to treat, like wellness or engagement, as a lifestyle choice, that employees must be continually cajoled into adopting,
or nudged or inspired into adopting, they hit a mathematical dead end. You are trying to use emotional levers to solve fluid dynamics problems.
So we go back to our seized engine block analogy from the intro.
It's the perfect way to look at it.
If you have a deeply disengaged worker or a completely stagnant team whose output has plummeted 12%.
Right, the internal friction is absolute.
Yeah, and you decide to throw a massive wellness initiative at them. You mandate a resilience retreat, you give them a subscription to a mindfulness app, you bump up the wellness stipend.
You are essentially pouring premium aviation fuel into a seized engine block.
The physical reality of that analogy is what makes it so chilling for executives to realize, I think.
It really is.
Yeah.
If an engine block is seized, meaning that internal resistance is absolute, adding more high-octane fuel does not magically create forward velocity.
It just can't.
It cannot.
Yeah.
The laws of thermodynamics completely prohibit it. Instead, the energy of that fuel, the capital, the time, the emotional labor of the manager trying to inspire the team,
It's all consumed by the internal friction.
entirely consumed.
It just burns.
It generates nothing but destructive thermal expansion. It heats the metal until it warps.
Wow.
You cannot motivate a deeply disengaged biological node that is trapped in a high-friction environment. You only burn them up. The energy you pour in creates zero work.
I really want you to think about that, speaking directly to you listening right now.
It's a hard truth.
If you are a manager, an executive, an entrepreneur, a team lead, how many times have you thrown resources at a stagnant team?
Oh, we've all done it.
You give them a pep talk, you increase their budget, you bring in a highly paid consultant to do a 2-day offsite on Synergy,
Synergy, right.
and you sit back and watch, and the team doesn't move any faster. They just get hotter.
Exactly.
The environment gets more toxic, the interpersonal stress levels spike, people start taking more sick days. But the actual output, the velocity of the code being shipped or the freight being moved, remains exactly the same.
That is the literal physical manifestation of thermal expansion in the workplace. The energy had nowhere to go kinetically, so it manifested as thermal waste.
So how do we stop that?
To stop that from happening, to manage an organization as a physical system, an executive must master 3 foundational properties of thermodynamic engineering.
We have to strip away the HR vocabulary entirely, don't we?
Completely. We have to start talking about synergy and culture fit. We have to look at exergy, entropy, and systemic friction.
And the text repeatedly hammers home that these are not metaphors. Like, we aren't being poetic here.
No, they are literal mathematical constraints governing the biological energy of your workforce. Let's define the variable, starting with the first one, exergy.
Exergy.
Yeah.
E subscript X, right?
Mathematically, yes. Exergy is the theoretical maximum ability of a system to do useful work. It is the highly ordered, available kinetic energy within your system before it inevitably degrades into thermal equilibrium.
Okay, I want to pause here because the text makes a brilliant distinction that I think is crucial for us to unpack. It differentiates between just regular energy and exergy.
Right, they're not the same thing.
It uses the example of a perfectly quiet room. The ambient air in a quiet, climate-controlled room possesses energy, right?
Tell me of it.
There are billions of molecules bouncing around at hundreds of miles an hour.
Yeah.
But because the room is perfectly at rest, because the temperature is uniform and there's no pressure gradient, that room possesses absolutely zero exergy.
Exactly.
It has zero capacity to push a turbine or do any useful work. It's just static noise.
That is a vital distinction. If we map that onto a corporation, exergy is the raw, unadulterated capacity of your top performers to execute complex tasks that move the business forward.
So it's the actual engine output.
Yes. When an elite engineer writes an elegant piece of code that solves a critical logistics bottleneck, they are converting exergy into forward spatial displacement.
Exergy is the engine.
It is the only thing that actually moves the enterprise forward against the resistance of the market.
So exergy is this highly concentrated, available power to do work. What does this look like biologically? Because let's be real, we are talking about human beings.
Biologically, exergy is closely tied to ATP, or adenosine triphosphate.
The cellular fuel.
Right. This is the organic compound that provides energy to drive almost every process in living cells. Your brain alone consumes roughly 20% of your body's total metabolic energy.
20%.
So when a highly skilled employee is deep in flow state, engaging in intense, productive cognitive labor, they are literally burning cellular fuel at a massive rate to structure information.
That is the physical reality of Exergy in a knowledge economy. It's not magic, it's calories and ATP.
Precisely.
Okay, so Exergy is our biological cognitive engine burning ATP to do useful work. But what about the second variable? Entropy, represented as S.
Entropy is the universal increase in randomness, disorder, and unavailable energy.
Right, the universe tends towards chaos.
Exactly. The first law of thermodynamics tells us that total energy in a closed system is conserved. It doesn't just vanish into nothingness.
But the second law?
The second law dictates that exergy, that highly ordered, useful energy, is constantly being destroyed through irreversible processes. And as exergy is destroyed, entropy increases.
And in organizational terms, the author calls this manifestation thermal mass.
Yes.
I love this term because it is so incredibly visceral. Thermal mass is the heavy, inert bulk of the workforce.
It's payload.
Right. They aren't actively sabotaging things. They aren't the villains of the story. But they are biologically at rest. They're the ambient air in the room we talked about.
They possess energy, but no exergy.
Yes. They consume payroll, they consume health benefits, they consume physical office space, and massive amounts of caloric energy. But they produce zero net new forward velocity. They are just mass.
Yes. They absorb the capital and the resources of the open dissipative structure, but they require massive continuous external gradients to move even an inch.
You have to constantly push them.
Exactly. So you have exergy trying to push the system forward and entropy acting as the heavy, dragging payload. But the true catastrophic threat to the organizational engine,
The part that blows it all up.
the specific variable that actually causes the system to violently break down and explode, is the interaction between exergy and our third variable, systemic friction.
Systemic friction.
Yeah.
This is where the text gets legitimately terrifying for any organizational architect.
It's the silent killer.
It provides this absolute nightmare of a quote. I'm going to read it verbatim because it's just so important.
Please do.
Quote, if a high exergy node is placed in direct operational contact with a high friction node, the exergy will be entirely consumed just trying to overcome the localized resistance. The work accomplished is zero, but the energy expended is massive.
Which brings us to the mathematical heart of our entire analysis today, the aerodynamic drag equation.
Okay, here comes the math.
Systemic friction actively resists motion. It doesn't matter how much exergy you have. If friction is too high, you will not move. And fluid dynamics gives us the exact empirical formula for how that resistance works.
Let's hear it.
Drag force, F sub d, equals 1/2 times the drag coefficient, C sub d, times fluid density, rho, times the reference area, A, times velocity squared, V squared.
Okay, let me write this down mentally. Force of drag equals 1/2 rho V squared CdA.
That's the one.
That is a lot of hard physics for a business discussion.
Oh.
Let's translate this into executive reality, because everyone listening to this has experienced this exact equation physically in their everyday lives. Imagine you are sitting in the passenger seat of a car, driving down the highway at 60 miles an hour, and you stick your hand out the window.
A classic, tangible example of fluid dynamics in action.
Right. You feel the wind violently push your hand back. It takes literal, physical, muscular effort to hold your hand steady against the air.
That's the drag equation executing in real time.
Now, imagine getting out of that car, walking down to a beach, wading into the ocean, and trying to sprint as fast as you can through waist-deep water.
The resistance is immensely different.
It's a wall. You are exhausted in 30 seconds, and you've barely moved 10 feet.
Even though your muscular output might be identical to sprinting on a track.
Exactly. And that massive difference is explained by the variables in this equation.
Right.
Let's break them down for the workplace, starting with critical, the fluid density.
Right.
In the physical world, waving your hand through the air is moving through a low-density fluid. Trying to swing your hand through a swimming pool is moving through massive density, so the drag force spikes.
Translated to a corporate environment, fluid density is the operating environment itself.
The culture.
The culture of compliance and communication. Are your engineers, your designers, your project managers operating in thin, fast-moving air? Meaning, Do you have a lean, agile environment characterized by high trust, decentralized decision-making, and immediate feedback?
Law.
Or are they trudging through thick, viscous molasses?
I've worked in the molasses. I think we all have.
A highly dense corporate fluid is a legacy bureaucracy where every single action, no matter how minor, requires passing through dense layers of compliance.
It's the company where deploying a minor code fix takes 3 weeks of committee reviews.
Exactly. The density of the environment physically exhausts the exergy of the worker before the work even reaches the market.
Okay, so that's the thick molasses of row. Next we have A, the reference area. In aerodynamics, this is the cross-sectional size of the object pushing through the fluid.
Right.
A needle pierces the wind. A giant flat piece of plywood catches absolutely all of it.
In the enterprise, the reference area is the size and scope of your initiative. How big is the project you are trying to push through the corporate fluid?
Right, the surface area.
If you launch a massive, cross-departmental, enterprise-wide software rollout, let's say migrating 10,000 employees to a new ERP system all at once.
Oh, a nightmare.
That initiative has a massive surface area. It is going to catch exponentially more friction than a small, isolated, autonomous strike team operating under the radar to solve one specific problem.
It's the difference between trying to push a needle through a block of cheese versus trying to push a dinner plate through it.
That's a great visual.
The dinner plate is going to require immense force and probably shatter the cheese. Okay, now let's look at C sub D, the drag coefficient.
This one is fascinating.
It is. This is the aerodynamic shape of the object itself. A sniper bullet is specifically designed to have a very low drag coefficient. It slips through the air.
Whereas a parachute is intentionally designed with a high drag coefficient to catch as much friction as physically possible to slow down a falling mass.
Which raises a profoundly uncomfortable question for any executive listening right now.
It does. How are your internal processes shaped?
Right.
When you design a workflow for a new product, is it sleek and aerodynamic? Is it designed as a bullet meant to pierce internal resistance and reach deployment as rapidly as possible? Or is it shaped like a parachute?
And let's be real, most corporate processes are parachutes.
Because they are designed out of fear.
Yes.
A parachute process is specifically designed to catch every possible compliance review, every legal sign-off, every middle management consensus meeting.
Covering all the bases.
Exactly. The company designs the process to ensure that nobody can be individually blamed if something goes wrong, which means everyone has to touch it.
You see this all the time. I remember working at a tech firm where we had an idea for a massive marketing campaign. The initial pitch was a bullet.
Yeah.
Fast, sleek, highly targeted.
And
Then legal needed to review the copy. That added a drogue chute. Then the brand safety committee needed to sign off. Another parachute deployed. Then 3 different regional VPs wanted to add their own localized flavor to the campaign.
parachutes on parachutes.
Exactly. Suddenly, the aerodynamic profile of our project was a massive, sprawling wall of silk, catching every ounce of systemic friction in the building. The creative team was burning ATP, pulling with all their might, but the drag equation dictates they will fail.
It's inevitable.
It took 9 months to ship what should have taken 3 weeks, and by then the market had completely moved on.
Exactly. And all of that, the density of the fluid, the reference area of the project, the parachute shape of the process, brings us to the final variable in the drag equation.
The big one.
The variable that the author calls the ultimate executive trap, velocity squared, V squared.
This is where it gets incredibly dangerous.
This is where organizations completely destroy their best people. Because the velocity variable in the drag equation is square, the relationship between speed and friction is not linear, it is exponential.
Break that down. What does that mean for a manager on a Tuesday afternoon?
Let's say you are a manager and you are behind on your quarterly goals. You go to your top performing team, your high exergy nodes, and you tell them they need to double their speed.
Just work harder.
Right. They need to go twice as fast, ship twice as much code, close twice as many deals. If they double their velocity, if V is multiplied by 2, the friction they experience doesn't just double. 2 squared is 4. The drag force they experience quadruples.
Wait. So if I ask them to go 3 times as fast, 3 squared is 9, the friction they experience goes up by a factor of 9.
Yes. You cannot simply order an organization to go faster. It is a physical impossibility to force velocity without first lowering the density of the fluid or smoothing the aerodynamic profile of the process.
Oh, yeah.
If a high exergy engineer is placed in a highly dense environment, forced to use a parachute-shaped process, and you, as the manager, demand they move at maximum velocity.
The drag force violently multiplies.
Exactly. The kinetic potential bleeds out as waste heat, and the biological engine suffers instantaneous dielectric breakdown.
Dielectric breakdown, that's the physics term. But in HR terms, we call that burnout.
Exactly. And this is a massive paradigm shift. Burnout is not a psychological failing.
It's not.
It is not a lack of resilience. It is not because the employee didn't use their meditation app. Burnout is the mathematical thermodynamic certainty of forcing high velocity against high systemic friction.
The biology literally can't keep up.
The biological organism physically cannot generate enough ATP to overcome the drag force you have subjected it to, so the system shorts out to protect itself.
That is a staggering way to look at it. If your best people are burning out, it's not because they are weak, it's because your company's aerodynamics are garbage.
Exactly.
But wait, I have to push back here. If moving fast against friction causes exponential drag and inevitably leads to burnout, how does any high-performing team ever exist? Like, how did the Apollo program work? How do elite startups ship products in weeks? There has to be a loophole in the physics somewhere.
There is, and the text refers to it as the technique exception.
The technique exception.
Which relies on a fluid dynamics concept called the Laminar maintenance principle.
Yes, the Laminar maintenance principle. Let's unpack this.
In fluid dynamics, accelerating a mass from a dead stop requires immense force. You have to overcome static inertia and escalating drag. However, once you reach your target operating velocity, maintaining that speed only requires enough force to counter the baseline drag.
And the text uses this beautiful analogy of an elite Olympic swimmer.
It's perfect.
If you watch an Olympic swimmer move through dense water, it looks terrifyingly effortless. They are moving at massive speeds, but they aren't thrashing around. The water isn't boiling around them. Why?
Because they hold a perfect rigid horizontal line in the water.
Exactly. They are intentionally minimizing their reference area, A, and they are dynamically smoothing their drag coefficient, C sub D, with every micro movement to maintain laminar flow.
Right. Laminar flow occurs when a fluid flows in parallel layers, with no disruption between the layers.
They're piercing it.
The swimmer is slipping between the layers of the water rather than fighting against them, and this translates beautifully back to the workplace. High operational velocity does not inherently cause burnout.
Human beings actually love moving fast.
They do. People love shipping great products, they love solving hard problems, they love the momentum of success. High velocity combined with terrible operational technique is what causes burnout.
So the goal of an executive isn't to artificially slow the company down so people can rest. We don't need a 4-day work week just to let the engine cool off if the engine is running efficiently.
Precisely. Slowing down a high Exergy team is a tragic waste of potential. The goal of what the author calls the Thermodynamic Architect is to perfect the hydrodynamic alignment of the firm.
Perfect the alignment.
You streamline the processes. You physically eliminate the parachute shapes. You thin out the molasses of bureaucracy. If you do that, your elite teams can sustain massive, blistering execution speeds using only a fraction of their metabolic exergy.
Moving at maximum velocity becomes biologically effortless.
Yes.
I love that phrase. Perfecting the hydrodynamic alignment. It sounds so much more actionable and rigorous than like team building or culture cultivation.
It's measurable.
Right. So to achieve this, the thermodynamic architect has to audit the organization and identify exactly where the turbulence is coming from. And the text notes that when aerospace engineers find friction on a fuselage, they don't politely ask the friction to reduce itself.
No, they apply lubricants, or they physically sever the points of high friction contact.
Which requires a radical shift in how we evaluate our employees.
Yeah.
We must classify the workforce, not by their psychological profiles, but by their physical properties.
So true.
Okay, let's go back to our hypothetical. We are back with CEO 8. It is 2 o'clock in the afternoon on that same Monday. The $14 million wellness initiative has been totally rejected.
They've hossed out.
Now he is sitting with his executive team reviewing the annual talent assessment. The CHRO fires up the projector and displays a traditional 9-box performance grid.
Ah, the 9-box grid.
I think everyone listening knows the one. It's that 3x3 matrix that plots employees based on soft metrics like, leadership potential on the y-axis and teamwork, or cultural fit on the x-axis.
The author refers to the 9-box grid as a semantic void.
A semantic void.
It is a chart that measures absolutely everything except the physical reality of work.
Right. So CEO 8 looks at this grid and he just orders the projector turned off. He looks at his executive team and says, "This grid tells me absolutely nothing about how this company actually consumes energy. We will no longer classify our workforce by psychological profiles. We will classify them by their physical energy states."
And this is where we bring in the telemetry. To prove this isn't just theory, the text takes the abstract laws of thermodynamics and maps them directly onto the 2025 Gallup macroeconomic workforce data.
Let's look at the numbers.
Now, a crucial disclaimer for our listeners. It is vital to remember that these percentages we are about to discuss are global macroeconomic averages. They are structural archetypes.
Right, so your specific company's numbers might look slightly different. You might be better, you might be much worse. But the global baseline is staggering.
It really is.
Gallup divides the global employee base into 3 distinct operational cohorts. And the text translates these cohorts perfectly into exergy, entropy, and systemic friction.
Let's start with the exergy. According to Gallup, only 21% of employees globally are actively engaged in their work.
Only 21%.
In our physical framework, this 21% is the kinetic engine. They possess highly ordered energy. They are the ones actually converting their biological ATP into forward spatial displacement for the company.
Right.
They drive nearly 100% of the forward kinetic momentum in the global economy.
I mean, just think about that. 100% of the forward movement comes from 21% of the people. They are pulling the entire weight of the world.
Yes, sir.
So what is the executive protocol for this group? How do we manage the 21%?
The protocol is absolute, uncompromising protection. You must remove all drag from their environment. You isolate them from the bureaucracy. You clear their laminar path.
Get out of their way.
You do whatever it takes, mathematically and structurally, to ensure they do not spend a single molecule of their metabolic ATP fighting internal friction. You do not make them sit in compliance meetings.
Nope.
You do not make them fill out expense reports in triplicate. You let the engine run.
Okay, protect the engine at all costs. That brings us to cohort 2, the 62%. Gallup calls them not engaged, or what the internet affectionately calls quietly quitting.
In physics, this 62% represents the entropy, the thermal mass.
The payload.
They constitute the massive inert bulk of the organizational weight. They possess raw biological energy, yes, but they have zero exergy.
Right.
They provide temporal presence. They show up at 9 a.m. and leave at 5 p.m., but they provide no passion or kinetic drive. They log in, they execute the bare minimum required to avoid termination, they log out.
And the text points out a massive trillion-dollar executive failure here. We spend billions of dollars every single year trying to forcibly convert this thermal mass into the kinetic engine.
Constantly.
We throw pizza parties, we give inspirational speeches at all-hands meetings, we hire motivational speakers, we mandate the resilience retreats. We are desperate to turn the 62% into the 21%.
And it is a mathematical impossibility that defies the second law of thermodynamics.
Wow.
You cannot forcibly convert unavailable energy into available work without an external energy input that vastly exceeds the potential return.
It's a net loss.
The manager will literally burn themselves out trying to inspire the uninspired. You will exhaust yourself trying to inspire concrete to move.
Don't try to inspire concrete. I literally need that embroidered on a pillow.
Yeah.
So if we can't inspire them, if we can't motivate them, what is the thermodynamic protocol for the 62%?
The thermodynamic architect must stop acting like a cheerleader and start acting as a cybernetic regulator.
A cybernetic regulator.
You build rigid, low-variance structural rails. You rely heavily on standard operating procedures. You assign explicit, highly legible instructions and automated workflows.
Right.
The goal is to structure their environment so completely that they can execute repeatable processes with absolute minimal cognitive load.
Make it mindless.
By standardizing their output, you prevent the thermal mass from devolving into active friction. You accept that they are payload, and you just direct the mass along the most efficient rails possible.
You don't ask the concrete to dance, you just pour it into the mold. Okay, that leaves us with the final and undoubtedly the most dangerous cohort, the 17%.
Yes.
Gallup defines them as actively disengaged.
The systemic friction. The active parasitic drag. They are not at rest like the thermal mass. They are actively generating opposing force.
Right.
In fluid dynamics, this is the equivalent of a highly viscous boundary layer triggering turbulent vertical flow that violently rips energy away from the aerodynamic body.
Right. We all know who these people are. They're the ones hoarding critical data so they seem indispensable.
Exactly.
They're the ones constantly gossiping and stirring up drama in Slack channels. They are actively undermining leadership, intentionally delaying approvals because they enjoy the tiny sliver of power it gives them, and they are actively sabotaging the efforts of your 21% kinetic engine.
They are. And the text notes a terrifying statistic here. This 17% cohort costs the U.S. economy alone approximately $2 trillion a year in lost productivity.
$2 trillion.
They are essentially a black hole for Exergy. They are converting the precious, finite biological energy of your top performers directly into useless waste heat.
Okay, but I have to ask the question that every single HR professional listening to this is screaming at their device right now. What is the protocol for the 17%?
The protocol.
Because in modern corporate culture, we are taught to save everyone, right? Do we put them on a performance improvement plan? Do we send them to conflict resolution seminars? Do we sit down and do an intervention to find out why they are so angry?
The text is unapologetic and completely unsentimental here. It provides a hard aerospace analogy. If an aerospace engineer discovers a surface defect that is causing massive parasitic drag on a fuselage, a defect that is creating so much turbulence it threatens to tear the wings off the aircraft in mid-flight, they do not attempt to negotiate with the defect.
Right.
They do not send the metal burr to an emotional safety seminar.
That is a brutally cold way to look at a human being. I mean, we're talking about a person's livelihood.
Yeah.
And the physics treats it like sanding down a metal burr on a wing. Does the text acknowledge how ruthless that is?
It acknowledges the biological reality of the system. The protocol is physical excision, absolute systemic quarantine.
Let's cut them out.
You cut the drag off the system to save the engine. There is no management technique, no PIP, no seminar that can rehabilitate active thermodynamic destruction. If you leave the 17% attached to the system, they will inevitably destroy the 21%.
Wow, okay. That is brutal. But when you frame it as systemic survival, it is physically logical. But this raises an immensely important question for you, the listener, and honestly for myself as someone who manages people.
Which is?
Are these states permanent? Like, if a biological note, a human being is currently classified as part of the 62% thermal mass, are they just doomed to be concrete forever? Is this a caste system based on physics?
No, and this is a crucial epistemic point that prevents this framework from becoming fatalistic. In physics, states of matter are highly fluid. They are entirely dependent on the boundary conditions of the localized system. Water is ice, liquid, or steam, not because of a change in its molecular identity, but entirely depending on the ambient temperature and pressure applied to it.
Right. Ice melts into water when the environment changes.
A human node does not spontaneously decide to improve in a vacuum. That is the core fallacy of the motivation delusion. But if the thermodynamic architect fundamentally redesigns the operational geometry of the firm, the physical states of the workforce will inevitably mathematically shift.
Let's talk about how to excite that thermal mass, the 62%. How do we turn the ice into steam? The text introduces a concept from chemistry: activation energy.
Activation energy is the minimum amount of energy required to initiate a chemical reaction and change a material's physical state.
Okay.
The 62% are currently sitting at thermal equilibrium because the corporate system they are trapped in does not offer a sufficient energetic payoff to justify the burning of their cellular ATP.
It's not worth it to them.
Exactly. If an employee looks at the system and subconsciously calculates, if I work twice as hard and burn double my metabolic energy, my only reward is a 2% raise that doesn't beat inflation, and I get assigned to 3 more committees, the biology simply refuses to expend the energy.
Exactly. It's a completely rational biological defense mechanism. Why burn calories for zero yield? So how do we engineer the reaction?
You change the boundary conditions. If the executive engineers a system that is highly legible, frictionless, and most importantly offers a direct, massive, proportional financial or structural return for kinetic work, the environment changes.
The pressure changes.
When the biological node subconsciously calculates that expending Exergy will yield a massive caloric and structural reward, they will voluntarily cross the activation energy threshold.
They will literally transition from thermal mass into an Exergy engine. They don't have to motivate them with speeches. You just have to fix the physics of their compensation and their environment. It's brilliant.
Yeah.
What about the 17%, the parasitic drag? Before we bring down the axe and machine them off the fuselage, can they be saved? Is it possible that the environment turned them into a metal burr?
The text strongly suggests running a structural diagnostic before executing the excision protocol. In fluid dynamics, turbulence is not always the fault of the air itself.
Really?
It is almost always the fault of the aerodynamic profile the air is forced to flow over.
So are they inherently defective people, or did the company make them defective?
Precisely. Are these individuals inherently toxic, or are they actually high exergy nodes that have been forced into a state of active drag by broken, zero-sum corporate processes?
Mhm.
If an elite engineer is repeatedly punished for moving fast, their exergy will sour into resentment. If you remove the bureaucratic friction, if you eliminate toxic performance metrics, and you clear the laminar path, you will often find that a localized source of extreme turbulence violently snaps back into perfect, high-velocity laminar flow.
Reattaching the turbulent flow. I love this. You can't motivate a system into a higher energy state, but you can re-engineer the system so that high exergy output becomes the most rational, lowest friction survival strategy for the organism.
Which transitions us perfectly into understanding what happens when a company gets this completely backwards.
Oh boy.
We need to look at what happens when an organization perfectly designs its aerodynamics to maximize friction rather than minimize it.
The friction factory. Let's set the scene for our micro case study. It's 4:00 p.m. on our hypothetical Monday. CEO 8 is reviewing a massive restructuring proposal from a newly hired VP of operations.
Right.
The VP is pitching a forced distribution curve across the entire logistics network, stack ranking. He wants to rank all the engineering nodes on a bell curve and automatically cull the bottom 10% every single year, regardless of absolute performance.
And his justification for this system is a classic piece of semantic void poetry.
Right. He slides the bell curve chart across the glass table, taps it, and says to CEO 8, it breeds healthy internal competition.
The author uses Microsoft's infamous lost decade under Steve Ballmer as the ultimate macroscopic historical example of this mathematical failure.
Yes.
During that era, Microsoft implemented a rigorous stack ranking system. And the result was not healthy competition. It was the deliberate, systemic engineering of aerodynamic turbulence.
Stack ranking mathematically engineers friction. But to understand why, to really understand the how of it, we have to look at the biological purpose of a manager in a physical system. And the text brings in this amazing, slightly mind-bending concept from physics, Maxwell's demon.
Maxwell's demon is a famous thought experiment created by the Scottish physicist James Clerk Maxwell in 1867.
Okay.
He imagined a microscopic demon guarding a tiny door between two sealed chambers of gas. By opening and closing the door to only let fast-moving hot molecules into one side and slow-moving cold molecules into the other, the demon could theoretically decrease the entropy of the system without doing any physical work, which seemingly violates the second law of thermodynamics.
It sounds like magic.
Yeah.
But there's a catch, right?
Yes. The catch, which was discovered much later by physicists like Leo Szilard and Rolf Landauer, is that the demon itself must expend energy to measure, sort, and store information about the molecules.
The sorting isn't free.
The very act of processing the information generates heat, which means the overall entropy of the universe still increases, preserving the second law.
Okay, so processing information costs physical energy. How does this apply to the friction factory?
In the corporate structure, the middle manager is Maxwell's demon.
The manager is the demon.
Their biological physical purpose is to act as a negentropic filter. They sit at the boundary of their team, the door between the chambers, and they sort incoming data. They filter out the chaotic, high-entropy external market noise, the frantic emails from upper management, the shifting requirements.
Oh, I see.
They absorb all that noise so that the high-exergy engineers inside the chamber don't have to burn their finite ATP dealing with it.
The manager absorbs the noise to protect the engine. Okay, I asked earlier what a manager doing this actually looks like on a random Tuesday.
It's very practical.
It looks like a manager intercepting a frantic, contradictory Slack message from the VP of sales, interpreting it, discarding the panic, and only passing along the 2 lines of actionable data to the engineering team.
Exactly.
The manager burns their own ATP so the engineer doesn't have to context switch. That is beautiful.
Yeah.
But here's where stack ranking gets so incredibly destructive. Stack ranking completely corrupts Maxwell's demon.
Because stack ranking replaces an external battle with the zero-sum game within the internal system itself.
Right. If you are a manager and you know you are mathematically forced by HR to fire 10% of your team at the end of the year, you stop looking outward.
You have to.
Instead of expending your metabolic energy sorting external market threats, you are forced to burn your ATP sorting internal HR bureaucracy. You have to play politics. And worse, you start intentionally hoarding low-performing nodes, the thermal mass, just so you have someone safe to sacrifice at the end of the year to protect your elite 21%.
You are intentionally hoarding entropy.
That's wild.
Think about the physics of that. Any performance system that incentivizes managers to retain low-performing nodes simply to protect high-performing nodes is mathematically suicidal. The manager's finite energy is entirely consumed by internal political friction. The negentropic filter completely fails, and the chaotic market noise floods the engineering chamber.
In my Microsoft example, you had teams intentionally hiding breakthroughs from other teams so they wouldn't look bad on this Tagout ranking curve. You've engineered a friction factory.
Yes.
You've turned your managers, whose job was to reduce drag, into the very parasitic drag that destroys the company. So what does CEO 8 do when the VP of operations proposes this bell curve?
He executes what the text calls the phase isolation protocol.
The VP asks what he's doing, and 8 just stares at him and replies, I am not negotiating with friction. I am executing a lockout tagout.
A great industrial term.
For those who aren't familiar with industrial manufacturing, lockout tagout is an OSHA safety protocol where you physically padlock the power source of a dangerous machine so it absolutely cannot turn on while someone is servicing it. It stops fatal electrical currents.
8 fires the VP on the spot. He doesn't debate the bell curve. He tells him, your transient current is short-circuiting my engineering team. You are permanently isolated from the system.
Boom. Cut off. A 4.000 p.m. termination.
The thermodynamic architect cannot afford the luxury of empathy when dealing with structural physics. Empathy for the drag coefficient means absolute cruelty to the kinetic engine.
That's a quote to remember.
If you fail to ruthlessly manage systemic friction, if you let the VP roll out a parachute process across the whole company, the result is catastrophic power loss across the entire enterprise.
Okay, as we near the end of this incredibly dense, fascinating structural diagnostic, we need to bring this all back to the telemetry we discussed earlier. The 21% exergy, the 62% thermal mass, the 17% friction.
We must firmly remind the listener, these Gallup variables are global macroeconomic averages. They are a starting point for understanding the physics of labor. They are not universal mathematical constants for every specific enterprise.
Right. You can't just assume your team fits these exact percentages. If you are running a highly toxic, bureaucratic legacy company that operates exactly like the friction factory we just described, your active drag might not be 17%, it might be 40%.
Very true.
And conversely, if you are running an elite, highly autonomous, well-funded strike team with perfect laminar flow, your thermal mass might be 0.
You cannot manage your company to the global average. You must mathematically measure the exact thermal state of your own localized system and execute the corresponding thermodynamic protocol.
Which leaves us with the absolute mandate for the thermodynamic architect. Capital is cheap. Labor is abundant. Organizations do not win by generating the most raw energy or hiring the most people.
Organizations win by systematically capturing exergy and maintaining the lowest possible coefficient of friction. Isolate the drag. Direct the mass along rigid rails, and let the kinetic engine run.
So here is our call to action for you, the listener. Tomorrow morning, when you log in, I want you to look at your calendar, look at your department's approval processes, look at your Slack channels, and ask yourself, what is my organization's drag coefficient?
It's the most important question you can ask.
Are you accidentally forcing your absolute best people to move at maximum velocity through thick molasses while strapped to a parachute? Stop trying to change the personalities of your employees. Stop trying to inspire them with wellness poetry. Re-engineer the aerodynamics of your company.
It is the only physical path to organizational survival in a high-friction market.
And trust me, you're going to want to subscribe and stick around for part 5 of this series. We're going to dive deep into the biological delusion of multitasking, a terrifying phenomenon known as context thrashing, and the violent ATP tax of Landauer's erasure on the human brain.
Oh, that's going to be intense.
It is going to fundamentally change how you view a simple Slack notification.
It will be a fascinating exploration of information physics. But before we leave today's deep dive, I want you to consider one final, highly provocative thought that builds directly on what we've unpacked today.
Okay, lay it on us.
We've spent a lot of time talking about burnout as dielectric breakdown, the catastrophic failure caused by forcing velocity against friction. But consider this alternative. If your organization's aerodynamics are perfectly designed to maximize friction rather than forward velocity, what if your top performers aren't actually burning out from the workload?
What do you mean?
What if they are intentionally radiating waste heat as a highly evolved biological defense mechanism against a system that refuses to let them move forward?
Wow. That changes everything. Are they actually broken, or are they just highly intelligent organisms refusing to pour their precious fuel into a seized engine block?
Yeah.
Picture this. There is just water leaking literally all across the break room counter.
Oh, man, a total mess.
Yeah, exactly. A coffee machine has experienced this total mechanical failure. I mean, the internal pump has completely seized.
Right.
It's a literal structural breakdown.
Yeah, you're looking at a machine that physically cannot perform its basic function anymore.
Right. And instead of, grabbing a wrench, management sits the machine down. They tell it that its morning contributions are highly valued.
Obviously.
And they buy a subscription to a mindfulness app.
Naturally. Well, predictably, the outcome was exactly zero coffee.
Zero coffee. Big surprise there.
Yeah. The machine still couldn't perform its core function. But what the source points out, which I find brilliant, is that it did radiate a massive amount of waste heat.
That is so true. That's the question we'll leave you with. Until next time.